Hey, all you German folks, today we're coming to you live from the office in my house. We're going to talk to you today about derivatives of trigonometric functions. Hopefully this is a benefit to you. I'm going to show you two derivatives, how to find them. But then based on that, you should be able to calculate all six trigonometric function derivatives. And then from there, we will expand our knowledge of derivatives of trig functions. But for right now, we're just going to focus on the basic six. All right. So for our first question, we're going to look at, what is the derivative of f of x equals sine x? That's what we're going to look at right now. Okay, so let's do this. So here we go, the derivative of sine x. So the only way to calculate derivatives without proper rules is to use the limit definition. So here we go, the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Now, normally when we calculate limits, we just plug things in. So if I plug in h is going to 0, notice I get sine x minus sine x, and this is going to 0 also. So we have a 0 over 0, and that's just not gonna work. We don't know what we're doing. Okay, so now what I want you to notice, we know what this is. If you need to, go back to your notes from pre-calculus or find it on the internet. But this is the same as the limit as h approaches 0 of sine x cosine h plus sine h cosine x minus sine x all over h. Okay, now that probably means not a whole lot to anybody. And even when we look at this, it's still going to be 0 over 0. So we're going to have to simplify this in some fashion. All right. So now I want you to know, I'm going to rearrange this. So I'm going to just switch these two places. Okay, so the limit as h approaches 0 of sine x cosine h minus sine x plus sine h all over h. And what you should notice is that there's a sine x in both of those. And so now what we're going to do is we're going to factor out that sine of x. Okay. Let me scroll down here a little bit. All right, so let's do this. The limits as h approaches 0, we're going to factor out that sine of x. And what I'm going to do is I'm going to split this fraction in half. But when I split the fraction, I still have h in the denominator here as well. All right, so you'll hopefully see what I mean. So sine of x cosine h minus 1 all over h, and then plus sine h over h. Okay, so these still have the limit applied to it. Okay. Apologies for the pause. You may have noticed I made a mistake here. So let's go back. All right, when I switched them around, here, I brought the sine h there, but I didn't put the cosine x there. So there should be a cosine x here also. So cosine x. So let me come down here to this one. So that cosine x should be there also. I've had teachers tell me with this, if I make a mistake, I got to just start over. But I think we're okay. So hopefully you'll see that here we have, oh, what happened there? Let me erase one more time here. Let's try this again. So this should be cosine x here as well. All right, and all of that. Now, now we're better off, right? Things are progressing well. Okay, now you may or may not remember this, but this limit right here, cosine h minus 1 over h, that goes to 0. So when I plug in h approaches 0, that what I've circled there, that limit is 0. So this is going to equal sine of x times 0. And this limit right here, okay, you may remember we talked about this in class, that goes to 1. So plus 1 times cosine x. And so when we simplify that, what we get, that whole expression right there just equals cosine x. So to recap, and this is something you can know, you don't have to know this derivative and the limit, you don't need to know that, but the derivative of sine x equals cosine x. Okay. Let's take a look at this from a graphing perspective. Nope, that's not what I want to do. There we go. Okay, here is sine of x, and I'm going to let Desmos graph f prime of x. So notice that's a very similar curve. You've probably seen that before, because notice I'm going to turn on g of x equals cosine x, and the derivative and the cosine x graph are exactly the same. Okay, so what happens if I change this to cosine x? Let's see what happens. Okay, what's the question is, what is the derivative of cosine x? Let's go back to Desmos. All right, and so, well, there's a lot going on there. All right, so there's the cosine x. There's its derivative. It looks very much like what we've seen. But let's turn on sine of x, because that would be my guess. But notice they're not the same. But in actuality, the derivative is the opposite. Can you see that? So if I throw a negative on here, now they're the same. So hopefully you'll see the derivative of cosine is negative sine. So let's formalize that. Okay, so if we write this out, the derivative of cosine x equals negative sine x. Okay, so now I'm going to show you one more example, and we're going to look at what is the derivative of tangent x. Okay, and so for that, we don't have to now go through that whole limit process. I'm going to show you a way, because we already know what the derivative of sine and cosine are, and we have already used some rules. Now remember that the tangent, you remember from pre-calculus, the tangent is sine x over cosine x. Okay, and now notice what we have. This is a quotient. Okay, oh boy, that's a quotient. So what we're going to do is we're going to use the quotient rule. We're going to take the derivative of sine x, well that's cosine x, and then times the denominator, cosine x, minus the top, which is sine x, times the derivative of the denominator, which is negative sine, which we just learned, all over the denominator squared, so cosine squared of x. Okay, so if we work this out, notice I have a negative and a negative, so this is cosine squared of x plus sine squared of x, still all over the cosine squared of x, but you guys remember from pre-calculus, cosine squared of x plus sine squared of x, that's just 1. So we have 1 over cosine squared of x. And we now have that the derivative of the tangent equals secant squared of x. Because 1 divided by cosine squared, that is secant squared of x. All right, next slide I'm going to show you is all 6 trig functions with their derivatives. This is something you will need to know, and then we might show you where some of those come from, but you can always generate them from the first two, knowing what the derivative of the sine is and the derivative of the cosine. So here are all the 6 derivatives you need to know. That kind of seems like a clustered mess. If you need to pause it, take a picture of it, help you remember it. But the reason I split it up this way, if you notice on the left, it's the derivative of sine, tangent, and secant, and all those derivatives are positives. Okay, if you look at on the right, it's the derivative of all the co-functions. Okay, everyone on the right starts with cosine, cotangent, cosecant, and all their derivatives are negative. But notice that they are just the same as what's on the left. So for instance, the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant. It's the opposite co-functions. Okay. Hey, thanks guys for watching. I know we got a little long-winded, but this is what happens when you get excited about the math and you just love what you're doing. All right, so we'll see you in class.